which is equal to 2.63 times 0.36, which gives us this value, which is the time that takes for the clay layer to reach 30% of consolidation. So question 3 is also over. Now we're gonna go through question 4. In question 4, a raft foundation, a rectangular raft foundation carrying a net pressure of 145 kilonewton over square meter is located at a depth of 4.5 meters below the surface in a deposit of dense sandy gravel 22 meters deep. The water table is at a depth of 7 meters, and below the sandy gravel is a layer of clay 5 meter thick, which in turn is underlain by dense sand. The value of MV for the clay is given, which is equal to 0.22, and the question is asking for the settlement below the center of the raft, the corner of the raft, the center of each edge of the raft due to consolidation of the clay. So this is our clay layer, this is our sand, this is the raft. In order to determine the settlement of the clay layer, we need to calculate the change in the effective stress in the middle part of the clay layer. So this is 2.5 meters, and this is 22 minus 4.5, which is equal to 17.5. So the distance from this point to this point is equal to 20 meters. So at the depth 20 meters below the raft, we have to determine the change in the effective stress, which we know how to do it. We learned it in the previous chapter. And after we determine the change in the effective stress, we are going to use this equation. SC is equal to MV times delta sigma prime times H, and H is the depth of our layer. So it's delta sigma prime times 5. So the only value that we need to calculate is this delta sigma prime for each of these 4 points, and I'm going to explain how to do it. So for the first point, which is point 1, this is our point 1, and this is 30, this is 20. So we have this rectangle, we have this rectangle, we have this rectangle, and we have this rectangle. So we have 4 rectangles that have the same corner at point 1. This is 4.1. So M is equal to 30 over 20, which is the depth. This is Z. 1.5, and n is equal to 20 over 20. And based on m and n, we can determine IR using the graph that we had in chapter 3. So IR would be 0.194, and we have 4 rectangles, so delta sigma would be 113. This is for point 1. For point 2, this is point 2. We have one rectangle here. We have another one here. This is 60. This is 20. So m would be 60 over 20, which is equal to 3. N would be 20 over 20, which is equal to 1. Using the graph, we have IR equal to 204, and delta sigma is equal to 59. For point 3, this is point 3. We only have one rectangle. This is 60, this is 40. So m is equal to 60 over 20. N is equal to 40 over 20, which is equal to 2. IR is equal to 0.238, and delta sigma is equal to 35. And finally, for point 4, this is point 4. We have a rectangle here, and we have this rectangle here. This is 30, and this is 40. So m is equal to 30 over 20, 1.5, and is equal to 40 over 20, which is equal to 2. And IR would be equal to 0.224, and delta sigma would be equal to 65. So for each point, we have the value of delta sigma, 0.1, 2, 3, 4. This is delta sigma, and this is SC, which is equal to MV delta sigma H. So for point 1, we had 113, 59. This is 35. This is 65. And we only need to put this value here, which gives us 124, 65, 38, and 72. So for each point, we calculated the change in the effective stress due to the load, and then using that value we could calculate the settlement at each point behind the raft. Thanks for watching the video. Please let me know if you have any questions.